Welcome to this second meeting, where we will be taking a closer look at technology and safety in agriculture. Today's topic will deal with the importance of the ISOBUS protocol as an answer to the needs of precision agriculture. ISOBUS is a protocol that allows communication between tractors and implements, an exchange of data in practically an international language through a single console. Of course, this is just a small summary of what today's topic is all about, and that's why we have invited our guests to tell us more about this very complex subject. In fact, next to me, I would like to greet Walter Righetti, Head of Simol Research and Development. Welcome, Walter. And directly connected from the University of Bologna, Professor Morelli. Welcome, Professor.
Thank you. Good morning to you too.
The connection is good. Can you hear us well?
Yes, thank you.
Very good. Then we can begin. Now, before asking the first questions, I think it would be a good idea to invite our viewers to connect to our website, where they can ask questions or put any queries they might have directly to the Simol experts through the website. And I would also like to extend an invitation to subscribe to the newsletter so that you can always be connected and informed about our latest news and also about our next web shows. My first question to you, Professor. There is a trend which is revolutionizing the world of agriculture. What do you mean by precision farming?
First of all, the concept of precision in the broad sense concerns an attitude relating to the way we work, so we can apply it in general to all our types of activity. So I would say that the concept of precision encompasses, in a sense, the synthesis between effectiveness on the one hand and deficiency on the other. Therefore, our ability to fully achieve the objective of the mission, to produce the expected result, but to achieve it in an extremely efficient way, therefore optimizing the available resources. And this is an issue that today can no longer be put off, especially if we think of its application in agriculture. So it is absolutely essential to use raw material resources. I'm thinking of water, for example, for irrigation. And not only that, it is also necessary to carry out precise processing in terms of the time needed to produce it. So optimizing and reducing processing times is a part of the broader context of precision. Because, for example, it enables us to save fuel. And in the end, precision becomes, if you like, one of the essential ingredients of quality. We could also give some specific examples of how precision processing can be applied in the agricultural context. If we think of the distribution of water for irrigation, or pesticides to contain an infestation, or even the distribution of fertilizers, the concept of precision lies in the ability to distribute exactly the right amount of product in each individual area to be treated, which could be the root ball rather than the leaf of the plantation. And this is where a very important technological challenge arises, because it is clear that we need to manage information. First of all, to understand which areas of the soil are more or less wet, so as to be able to calculate and prepare the distribution of the right amount of water necessary in each individual area. And we must, of course, manage this information and make it applicable through an integrated technological system capable of creating semi-automisms, or automisms that then make make this extremely important concept of efficiency operational.
So you've almost answered the second question I wanted to ask you, i.e. that in order to optimize work and resource consumption, we need increasingly precise means.
Absolutely. This is a major challenge that requires continuous investment in research, development and innovation. Clearly, this type of investment always pays off, because it is a part of the logic of quality work. However, we obviously cannot think of wasting pesticides, for example, by distributing them outside an area where they are not required, because in addition to failing to optimize the use of these resources, we are also causing damage to the environment. And we must not forget that we are in an era in which we must constantly keep in mind sustainable development. So precision and the increasingly widespread introduction of automation in agriculture is not just a desire, but a real necessity. In conclusion, I would like to emphasize another aspect that I believe to be very important. The IT support for this technological process also allows us to keep a complete track of all the information relating to the work being done. So we have the possibility of producing printouts to optimize in the future whatever is necessary to complete work in the field and to continue to provide this technological precision, and therefore continue to maintain operational efficiency over time.
Thank you, Professor. Rigetti, I'd like to put the next question to you. The main topic today is the ISOBUS. What exactly is the ISOBUS protocol?
ISOBUS is a data exchange system between tractor and implement that was created in the mid-1990s. Its technical name is ISO 11783, and it is practically a standardized protocol. Let's say it is an agreement between implement and tractor manufacturers to generate a data exchange between tractor and trailer. So, in this case, any ISOBUS-compatible implement, once connected to an ISOBUS-compatible tractor, will work perfectly. Before the mid-90s, when this system made its debut, implementations used electronics. Unfortunately, these electronics were proprietary, and each manufacturer used its own system. So if a farmer used several implements with the tractor, his cab would be filled with monitors of all shapes and sizes, because every brand needed a monitor.
It's also a bit difficult to manage.
Not only that, but think of the rear of the tractor, where there was a multitude of connection cables, because clearly each system only needed one connection cable. So this system led to complete standardization. Inside the cab is a monitor called the virtual terminal, a touchscreen which permits giving commands and receiving information from the implement in complete comfort inside the cab.
So you consider this absolutely necessary?
Let's say that precision farming was only able to start and exist thanks to the ISOBUS protocols. Otherwise, it was almost impossible to fully support all the demands and requirements that precision farming
requires. Certainly, Professor. What benefit can the end user, i.e. the farmer, have by choosing a device that complies with ISOBUS technologies?
Before talking about the benefits, however, I too would like to emphasize the absolute need for a communication system which, let's say, is recognized in a standardized manner by both tractors and implements, which of course can be manufactured anywhere in the world. Because if our objective is to produce precision, at this point, we absolutely must manage information in an integrated manner between all these players. So we need communication support. The ISOBUS network was created precisely for this reason. Otherwise, we would not be able to produce intelligent automation if we did not have the possibility of transferring the data detected by the sensors on board an implement to the tractor, which then perhaps has to make decisions on the adjustment of the operating speed. To give an example, the case of harvesting straw to make hay bales comes to mind. In this specific type of operation, the implement that is harvesting the material features the sensors needed to know when the bale will be ready. So the benefit lies in the fact that through the ISOBUS communication protocol, the implement is able to communicate in advance to the tractor the exact moment when the bale will be ready. So we can develop integrated, intelligent, automatic control systems through which the tractor itself can adjust the speed and reduce it to zero at the exact moment when the bale is ready to be deposited on the ground. And here we return to the benefit of precision, because by optimizing working time in this way, we naturally have considerable fuel savings.
It kind of ties everything together. This system is really smart. That's the right word. Because we have achieved truly incredible technology in agriculture. Rigetti, what was Simol's answer to having a smart jack capable of communicating according to the ISOBUS protocol?
Simol's answer was Novel Jack. Novel Jack is an interactive jack connected to the tractor via this cable and able to exchange information with the control units on board the tractor.
In fact, you call it the Smart Jack, right? And how does Novel Jack interface with and integrate into the ISOBUS protocol?
Well, simply in the way I explained earlier, through this connection plug, which is a dedicated ISOBUS plug, a single cable through which both the necessary electrical power and all the data pass, and this control unit, which is connected to the control unit on the tractor. All this data flows into the virtual terminal, and from there, you can give commands to the jack. Obviously, the jack is very high-tech. It is equipped with very advanced sensors that can continuously monitor what is happening to the jack itself.
We'll talk about this in the next web show, but in the meantime, I'll ask the professor one last question. Several points emerged, namely increased productivity and reduced physical labor, efficiency in total safety. Are these the benefits?
It is clear that the architecture of a precise system that requires interaction between different tractors is based precisely on the distribution of intelligent logic. So each component is equipped with a residual control unit or control system. And in this case, Novel Jack is an intelligent center within the system as a whole. Then, of course, each implement will have its own electronics and intelligence logic implemented, just as each tractor has its own control electronics. So the distribution of these points where information from the sensors is collected, because each implement has its own sensors, just like Novel Jack has its own. In addition to this, there is the possibility of carrying out local processing of the information, which also benefits from sharing. So each individual implement shares its data through the sensors within the ISOBUS network, so that all players involved can benefit. At this point, each system can, on the one hand, produce its own automatic operation on the basis of information collected from the entire ISOBUS network. But on the other hand, it can also implement passive rather than active safety procedures that take into account the precious database of information collected in real time in the field from all the implements connected to the ISOBUS network. This is one of the most important benefits of the ISOBUS network from my point of view.
Well then, Professor, would you summarize the points made in this web show?
The central topic is certainly that of precision. So precision, which from a historical point of view may have been more linked to mechanical operations. So we all have in mind the term precision mechanics, which was created by the history of our industry. But in the context of which we live today, it is absolutely essential to also introduce precise processing into agriculture, because we can no longer put it off. We are somehow obliged to make the best and most efficient use of the few resources available. So the concept of precision is absolutely central. Then the problem from a technological point of view is how to achieve it, because in words it is very clear, very simple. We all aspire to improve the precision of our working techniques. But in order to put in place an articulated and complex system, such as that which characterizes agricultural operations, we require the endeavors of everyone. So we need the concept of standardization, which has been introduced and which is extremely important. We need a single standardized communication support. So we talked about ISOBUS support. And through all these ingredients, the electronics on the one hand that allow us to control the automatic systems, the communication support on the other hand that allows us to carry out a complete integration between all the implements. The combination of all these components allows us to continue to improve productivity in the agricultural sector in an increasingly precise and therefore more an effective and efficient way.
Well, thank you, Professor. I would say that in this meeting, we have explained the functioning of the ISOBUS protocol in a fairly precise manner. But I invite you to visit our website, where Simol experts will answer your questions, queries, and provide more in-depth information. And I also invite you to subscribe to the newsletter to always have information in direct time and, of course, register for the next web shows. I would also like to thank our guests Walter Righetti, thank you, and Professor Morelli. How are you in Bologna? Say hello for us.
Willingly.
Very well. Thank you to our guests and see you in the next web show.